In order to prove that these two triangles are similar, I have to find two sides of the triangle ABC are proportional to another two sides in the triangle DEF. And at the same time, the angle included between these two proportional sides in the triangle ABC must be equal to the angle included between these two proportional sides in the triangle DEF. That is, as you see here, I have the angle BAC is equal to the angle DEF. Now, if I want to find the ratio, the equal ratio, it must not include BC or EF. So it should be AB over DE is equal to AC over DF. Since the angle BAC is included between AB and AC, and the angle EDF is included between DE and DF. So now, if BAC is equal to EDF and AB over DE is equal to AC over DF, then these two triangles ABC and DF are similar. Now, I want to find the other two angles that are equal in these two triangles. So, in order to find this, I will use the ratio of similarity. Now, we can deduce that the angle ABC is equal to the angle DEF. You see here, the angle of vertex A is equal to the angle of vertex D. These are equal in the first ratio. What are the letters that are left? B and E. So the angle of vertex B, that is ABC, is equal to the angle of vertex E, which is DEF. So these two angles are equal. Now, using the same method for the second ratio, the angle of vertex A is equal to the angle of vertex D. What are the left letters? C and F. So the angle of vertex C, which is ACB, is equal to the angle of vertex F, which is DFE. So I write ACB is equal to DFE. And the ratio of similarity, I have AB over DE equal AC over DF, which I wrote in the proof. What is left? BC over EF. Now we want to solve an application on the second case, which is exercise number 7, page 93 on your copybooks. In this exercise, using the information of the figure, I want to find the length of OL. In the following figure, I have N is 2, ON is 4, GN is 3, NA equals 6, and AJ is 7 centimeters. I want to find the measure of OL. How can I find the measure of the side OL? So, I have to choose two triangles and prove them similar in order to use the ratio of similarity to find the measure of OL. What are these two triangles? Yes, as you said, it is the triangle LNO and the triangle GNA. So in the two triangles OLN and ANG, let's start looking for equal angles. So as you remark here, I have LNO is equal to GNA, vertically opposite angles. Now, we have to find equal proportional sides, which are, if I calculate the ratio of NG over NL, it is a 3 over 2. And let's calculate the ratio of NA over NO. It is 6 over 4. If you divide 6 over 4 by 2, it is a 3 over 2 also. Then NG over NL is equal to NA over NO. We have always to check for the condition, if the angle is included between the two equal proportional sides. So as you see here, LNO is included between LN and NO. GNA is also included between the sides GN over NA. So the condition is verified. Now, we can say that the two triangles are similar, having two sides of one triangle are proportional to two sides of the other triangles, and the angle included between those sides are also equal. So now we have NG over NL is equal to NA over NO, which is equal to 3 over 2. Now I want to calculate OL. I will write the ratio of similarity. NG over NL equal NA over NO equal to GA over LO equal to 3 over 2. I will take this ratio because here we find LO. So it is GA over LO is equal to 3 over 2. I will replace GA by 7 centimeter. So I will have 7 over LO is equal to 3 over 2. We will apply the crisscross method. 3LO is equal to 2 times 7, which is 14. Then I write LO is equal to 14 over 3. Now, we will add a small remark. I want you from the figure to calculate the equal angles we have in the two triangles. First, we said L and O is equal to G and A. So we have the vertex N is equal to the vertex N. So we will write the ratio of similarity, and in NG over NL, we will eliminate N. What is left? G and L. Exactly. The angle of vertex L is equal to the angle of vertex G, which is NGA is equal to NLO. Also here in the second ratio, we will eliminate the letter L, the letter N. So what's left? A and O. So we write LON is equal to NAJ. Now we will start with the third case. In the third case, in order to prove that these two triangles ABC and DEF are two similar triangles, simply I have to prove that the sides of the first triangle are proportional to the sides of the second triangle. That is, if I can prove AB over DE is equal to AC over DF is equal to BC over EF, then these two triangles are similar. Now, I want to find the equal angles. I will take the third ratio, BC over EF. Let's see. What's the angle facing BC? It is BAC. And what's the angle facing EF? It is EDF. So, I will write BAC is equal to EDF. Now, I will take the second ratio, which is AC over DF. AC is here. What's the angle facing AC? It is the angle of vertex B. Then ABC is equal to the angle facing DF, which is DEF. So I will write ABC is equal to DEF. And the angle that is left here is ACB is equal to the angle DFE. Also, you can find it from the first ratio, AB over DE. What's the angle facing AB? It's ACB. What's the angle facing ED? It is DFE. So it is ACB is equal to DFE. Now I want to solve this application on the case 3. I have the two triangles DON and TIR of given measures of their sides. I want to prove that these two triangles are similar, and I have to justify my answer. As you see here, I have no given about the angles, so simply I know that I have to use case 3. So, in triangle ODN, I have OD is 7 cm, DN is 8, and 10 cm for ON. In the triangle RIT, RI is given to be 12, IT equals 10.5, and at last RT is equal to 15. So in the triangles DON and DIR we have, first I will choose OD over IT, which is 7 over 10.5, which is equal to 2 over 3. The second ratio, DN over IR, it is 8 over 12. I will simplify by 4, I will get 2 over 3. And the last ratio for the remaining sides, which is ON over RT equal 10 over 15, which is equal to 2 over 3. Then I will deduce that OD is over IT is equal to DN over IR, which is equal to ON over RT, all of them equals 2 over 3. Then the two triangles are similar because of the sides of the first triangle are proportional to the sides of the second triangle.